Good evening, everyone, and Happy New Year. So we are starting our week 6 today. I'm just trying to check something. Okay, so this week we'll be covering string and file operations. Okay, let's start with the thing. Now, string is one of the, definitely one of the most important thing in programming. Um, in terms of data manipulation, strings are really, really important thing. And many of the things are known to, known to us already in regards to string, but we'll go through with that this lecture. So, for example, the word programming. So it's a string literal in which all individual characters are positioned as a list. So, for example, starting index is 0. So 0 is p and 0 position, right? And the length -1 is the last one. So we'll see that. Now, up until this point, we have been using single quote around the text to create a string literal. However, we can also use double quote, right? We can also use double quote, but we'll see that. But if a single quote indicates the end of the string, how do we include a single quote inside the string? For example, sometimes you would like to include a string literal in which we need to do things like that, right? This type of thing that this doesn't work. So how can we include a single quote, right? And what about the other spatial characters like new lines and tabs, right? If we go to the new line or tabs, how can we include those spatial characters? Of course, if we search in Google or in AI tool, we can find what are the special characters required and so on. Okay, escape character. Now in Python, the backslash is an escape character which changes how the character after it is interpreted inside a string. So that backslash is used to include any special character. Any character, for example, the quote, single quote in this particular case, we can include that within a string literal. So placing a backslash before a single quote tells Python that this isn't the end of the string, it's just a single quotation mark, right? For example, if we look at this example, that print single quotes aren't a problem. So if we don't use the backslash, what will happen is that it will create an error because this is the starting quote and Python will regard this as the end quote, right? It will create a problem, right? That's why I need to put a backslash to indicate that this is not the end of the string. It will continue. And this quotation, I need to print, right? So that's how this output includes the single quote. Okay, now from next week, definitely the classes will be on Wednesday, right? Always Wednesday. So only this week, the exception. But from next week, it will be on Wednesday. Okay. Now, another thing. Sorry. Okay. Now, these are the common escape sequence. For example, if I use a backslash and then another backslash, that means that this backslash will be printed, right? This single quote will be printed. That's why I'm using the single quote. This double quote will be printed. New line will be printed. New line is represented by small n, and backslash t means a horizontal tab. Some space will be created. So this is the common escape sequences. So if we try to look at the example here, is that Um, okay, so the print first line and then um, this one, right? Space, sorry, backslash n means new line, second line, right? So that's why we see in the printout that first line and then the second line is printed as a new line, right? So after this letter, actually the new line is printed, so it goes to the next line, and then I can print the second line. Now this one is interesting, print. So backslash slash, which means that the second one will be printed, right? This is a really interesting one, that this one, the second one is printed, and then this single quote would be printed, right? That's why I need, so this backslash and that backslash is used to print that relevant next followed up character, next character, right? Which is in the first case, I want to print the backslash. That's why I'm using another backslash to define that, right? To note that, okay, I need to print that backslash. And I need to print this single quote. That's why I'm using a backslash to indicate that I would like to print this single quote, right? That's so you can see that this backslash is printed here, and this single quote is printed here, right? And then the O is printed, this O is printed, right? And then that single quote is also printed like this one. That's why to give the indication that I want to print that single quote, I'm using this backslash immediately at the left, right? And then this is the forward slash, right? And then that forward slash is printed, okay? So this is a really an interesting kind of uh, things to ponder, right? That how, what I'm really doing to print them. Now, free, this is an interesting thing that single quote, and then I'm using the double quote. So when I use the double quote inside a single quote, I don't need a backslash. That double quote will be printed. However, if I use the print with a double quote, then internally inside I can use a single quote. I don't need a backslash for that. However, if I use a single quote, if I want to use a single quote inside, I need to use a backslash. In the same way, if I use the print command with the double quote, definitely if I use the double quote at the beginning, it will be ended by double quote, right? However, inside, if I want to print any double quote, I need to use a backslash, right? So that is the kind of system or the process, right? So free, again, print free. So here I can see that, I mean, both are actually same, right? Even if I use a backslash for, but I don't really need to. But if I use it, it will do that double quote print, right? It will print the double quote, and then the free, and then this double quote would be printed. And then, but again, I'm noting that if you want to see this difference, both are valid, right? So probably the first one is easy to follow, right? Easy to follow. Okay. I think any question you can just write in the chat. That should be fine. So far, I think it's okay. Okay, now alternative string literal syntax. So although you can use escape sequences to express any string you can think of, it can start to look a bit ugly, right? For example, like if you can see that this is what, it can be happen. So you can think what I'm trying to print, and then, you use the backslash. However, Python provides alternative ways of expressing string letters which you can choose between. Okay, we'll see that. Now, double quote strings. So you can use double quotes instead of single quotes, right? That we just said before. Changes which type of quotes need to be escaped. So useful when you need to include apostrophes. So for example, I don't need to escape. Now, um, of course, I don't, you need a single quote in the string. So it's probably better. I mean, if you can use the double quote um, to cover the whole thing. So if you use a double quote so what I'm saying is that if you can see the start and the end mark as double quote, then inside you can use a single quote, right? However, if you find the start and end mark as single quote, then inside you can use double quote without any backslash, right? So the trade-off, this is the trade-off, right? So what you really need as an output in your context, you can choose accordingly. Okay. The trade-off is that double quotes now need to be escaped, right? So for example, if I use, double quote as the start and end mark, then if I want to print a double quote inside, then definitely I have to use a backslash, right? So it isn't the real you, right? Any question you can ask me. I think that is the bottom line, that the end marker, if it is a single quote, then if you want to use a single quote inside, you have to use a backslash. If the start and end mark, like in this example, is a double quote, then if you want to print a double quote internally inside any word, uh, then you have to use a backslash to do that, right? However, if you use the double quote as the start and end tag, then to print single quote, you don't need any backslash. At the same way, if you use single quote as start and end mark, then to print double quote, you don't need any backslash. Okay, multi-line strings. You can write a string that spans multiple lines by using three single or double quotes, right? So multiple lines is an interesting thing. This avoids the need to use slash n. This is the new line, right? So, yeah, I mean, many programmers basically use slash n, right? But that's an alternative approach, that if you use um, three, three single or double quotes, then you really don't need to use new line. You can still use n inside multi-line strings if you want to, though, right? Yeah, I mean, you can use that. So think about this example, that print, then three double quotes, one, and then you entered and typed two, right? Um, so if you do that, you can find one, two, right? This way. Um, so of course, this is a command line interpreter. So in Colab, you can try to do that, right? So print and then just go to the next line and close it and run the code. Then you can see the printout like that. Similarly, print three quote, and then I'm using, so, since you're using three quote, this is the start marker, right? Start marker is three single quote. So definitely three single quote would be the end marker, right? Starting point and end point. Now inside, to use double quote, you don't need backslash, right? That we know. That if I want to use the opposite, the other thing, so if I use the single, and if I want to use the double marker at the double quote at the middle, I don't need any backslash. So double quote one, so this whole thing would be printed, right? So what I'm saying is that so this portion would be printed. That was actually printed. And then this is a new line. So definitely it goes to the new line, and then two and three. So you can see that for three, I didn't use new line marker, right? But if I use between 1 and 2 the new line, then the 2 goes to the new line, right? So that's what is actually happening here. If you think about the example, then it makes sense. So there it is actually, I mean, by pressing enter, I can go to the next line, I can print it. And since I'm using the 3 double quote, I don't need to put the backslash n. But if I use it, then it will put another new line, like 2, that happened to the 2, right? Because these two happened because of the new line thing, right? Okay. Now, indentation, one of the interesting thing regarding in this particular context is the indentation with multi-line string. So note that the space included in the string matters. So things can look a bit weird when code is indented, right? Okay, so for example, ring true. So if ring, then print ding dong. So this is an interesting thing that the tab is here. So the tab definitely will not see it. It's just a white space kind of thing. So this space would be printed here, right? So if you don't do it, then they should be completed the new line, right? So for example, if you do this way, if you don't put any, kind of indentation, then it would be printed like this. Now, probably I would like to look at an example into the Colab of this particular thing, what I'm trying to explain. Um, just hmm, okay. So here we see that um, like ring ding dong, right? So if I, for example, if I want to use that space, then I can see that the space is generated because of this space, right? This is what the for space, right? It's similar. That is generated. So this is what we are referring to. Okay. Back this thing. So check your understanding. So this is your task. Let's see what you can answer, right? Use a double quoted single line string literal to express the following text. So is it cheap, comma, or cheap? So how can you print that inside a print statement, right? Like this way, right? This is in the print command. So if you can write it into the chat, then we can discuss on that. So please work on that. So how can you use a double quoted single line string literals to express the following um, text? If you have any confusion, I can explain again, but can you please try? Like what I'm saying is that you have to use the, the new line or double quote, single quote, or 3 single quote or 3 double quote, whatever you'd like to use. How can you print that? How can you give the output of this statement? Anyone? Mm, is the okay? Okay, so this is the output. Like, is it cheap? So, for example, I use the comma and then the new line and then or cheap, right? So since I used the double quote here, since I use the double quote as a start and end point, then um, I need to use backslash to hold that double quote, right? Then it can be printed. Okay, and for this new line, it will automatically go to the new line. Is it okay, everyone? I mean, I'm not sure. The sound and everything is okay, right? I mean, you can respond in the chat, then I can proceed. Any question from the, or is it okay? Okay, excellent. Okay, so that is how we can use the single quote or double quote thing. Okay, now the multiple strings. So a string is a sequence of characters. The length of a string is the number of characters in the string, right? So len function, the len built-in function can be used to identify the length of a string literal. For example, if I use len uh, um, avocado, right? So it returns 7. So 1, 2, 3, 4, 5, 6, 7, 7 characters. However, it starts from 0, ended at 6, right? So 0 to 6, it is 7 characters. Okay, so that is one interesting point, that the index is less than the last index. Index of the last character is actually length minus 1. An escape sequence counts as one character, right? For example, this is an interesting thing, that A and then new line. So these two characters, which means backslash and N, they both together will be counted as a single character, right? They together will be counted as a single character. Therefore, there are 3 characters. So length A backslash NB. So backslash N means new line, right? So it will be 3 characters. 3. That's why it will return 3. The index of character indicates its position in the string. So indices start at 0. So the first character is at index 0. The last index, right? The last index is the length of the string minus 1. Okay, so if you look at this example, that star words, right? If I put that string literal into consideration, then we can see that the 0 index is STAR and then the space character is space, right? This white space is actually 4, it's index 4, and then words is 5, 6, 7, and 8. So the total length is actually 9, right? 1, 2, 3, 4. Space is another character, right? 5, 6, 7, 8, 9. So 0 to 8. So the character at index 1 is T, and the character at index 4 is the space character, like this is space, right? So this is how, so this is the main point of string, that how string is represented. String literal is represented in Python, in other languages, many other languages as well in the same way. Okay, now negative indices, that is unique in Python, right? So and it has a lot of usefulness, is that in Python you can use the negative indices to count backwards from the end of the string, because sometimes we don't know the length of a string. So I don't know what is the last index, right? Because the last index must be length n minus 1. But if I know that the last index is also minus 1, then the Python itself is giving programmer some extra benefit, extra control to identify almost every characters within the string literal. I mean, identify the position of every character. Because if the last one is minus 1, then the next one, which is the immediately left side character of the the last one, it must be minus 2, right? And so on. So what I'm saying here is that star wars, so the if the last one is minus 1, we can see here that this is the minus 1. So then definitely the next one is minus 2. Next one is minus 3, minus 4, minus 5. and the first one would be -9. Now, I don't need to do first one because the first one is also 0, right? This is also 1, this is also 2, this is also 3, right? 4, 5, 6, 7, 8, right? So in two different ways, basically, so in two different ways, we can basically identify the index of the character. And the first and last one is really, you know, important to identify, because then actually we can scan through, right? So this is the advantage that the negative indices, Python has that idea. Now the character at index -1 is the last character of the string. In this case, it is S. Okay, so what is the second last, which must be -2, right? And so on. Okay, indexing any string. So you can use square brackets. So now the position is clear that, in two different ways, using positive indices and negative indices, we can identify, we can pinpoint the position of each character inside the string literal. Now, how to represent, how to show, how to print out the individual characters or character at a particular index point, right? That is the next focus of the study. So how to index? You can use the square bracket to retrieve a character by its index. So this is the idea, that you can use the square bracket to retrieve a character by its index. And we know about index. The first one is 0, last one is -1, right? And in two different ways you can get the sequence. And second, and next point is the square bracket. So movie, suppose Star Wars. So if I type movie 0, of course in Colab you have to use the print, right? Then it should print, S. Now this is called indexing. You can use normal or negative indices. So just to make it simple, I mean, in terms of understanding for the beginner, so if I go here, say, suppose here, that is actually I'm talking about that movie, I put Star Wars and then movie. So I just use one at a time, sorry. Say, um, -1, right? So movie -1, and if I type it, I can expect S, right? The last one. So we can see that. We expect that we can get the last one, right? So similarly, if I use 0, then we can expect the first one. So I just do one thing, Star Wars, suppose 2, right? Suppose this is the movie name. So 0, if I type 0, then I get the first one, and if I get -1, right, I can get 2. So this is the 2. This is the last one, right? So if I put -2, I expect to print this space one, right? And this is what actually happened. The space one is printed, right? And similarly, if I want -3, I expect to get the S. So this S, right? -4, I can get R, right? So similarly, if I just look at, we looked at 0, so what about 1? So if I put 1, then T, right? Okay, what about the 10? So 2. So, okay, let's see. This is an interesting one. So this is the index error, right? So if I put something which is beyond the range, we can get. Now, in case of 10, that's an interesting thing, that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is also 2, right? That's why we are getting the 2, right? But even in 11, if I put 11, then I can get the error, right? So this is the exception, right? So index error is string index out of range. So it is trying to give the error thing, right? Similarly, if I use say minus, a big range, which is again beyond the range, we can expect the similar error, right? Okay, good. Now I come back to the thing. Slicing a string, the next topic. No, you can imagine that we are looking at different concept within a string. And finally, actually, I'll show you a website link in which you can find all those listed. Of course, there are many websites available in AI tool. You can find a lot of help. Try to use those tools in even in the future or while doing the coding, because you cannot remember many things, right? Even you don't need to remember. So that example will give the idea that how you can use those functions to manipulate the string, because manipulating a string that we're learning today is very essential in data analysis, right? In data analysis, that is a major nowadays, one of the major industry, right, in IT, which is the data engineering or data science and so on. There actually, the string manipulation is one of the fundamental thing. Okay, in Python, basically that we are reading now. Okay, now how can we slice a string? So you can use the square brackets to retrieve a segment of a string that is called substring, right? A very important term that is called substring. Okay, so this is called slicing a string. So if we look at this example, movie, Star Wars. Now, movie 0 to 3. So 0 to 3 means that look at the colon, right? The colon, the left one is the starting index and the right one is the last index. So you start from the 0 position, end at the third. Third means fourth, right? So now there is an interesting point, which is 0 to 3. So you start from 0 but ended at 2. So what is the last one? You must continue up to the last index minus 1. So 0 is S, T, and A, right? 0, 1, 2. So I can expect STA to be printed. Now, movie -4 to -1. So last one is -1. And we know that -1 is the last character, last index, right? So the last index to -4. So it's really hard to identify -4 first. So -1 is the last one. So if this is -1, this is, so I'm just trying to do one thing here, that if it is -1, then this must be -2, then this must be -3, then W must be -4, right? So W is -4. So so -4 to 1, right? So I can, so what's really happening here is that from starting from -4, it goes to -2. It goes to -2 because the last index, it doesn't reach up to the last index. It reach one position before last index, which is -2, right? That's why var is printed. Any question from anyone? So I think if you look at the example and then you can, it makes sense. So that is actually explained here clearly, that notice that the character at the first index is included, right? So this is an interesting point. The first index is included, but the character at the last index is excluded. This is really, really important, right? The last one is excluded. So it will reach before the last character, right? Right. So I think that's the main point here, that the first index is included, but the last, the character at the last index is excluded. Okay. Um, okay. Now, more example we'll go through. Now, this is another very popular term. Sometimes I don't need to include the first or the last one, right? So if you omit the first index, all the characters from the start of the string are returned. So, which means that if you don't include the first index, if you keep it empty and start with the colon sign, then what will happen is that all the characters from the start of the string are returned. Therefore, in this particular example, slash to 4, right? Which means 0 to 3. So 0 is S, T is 1, A is 2, and 3 is 4. So star is returned. Now movie minus 4 to and the end character. So if you omit the second index while slicing, all the characters to the end of the string are returned. To the end, now the end of the string are returned, right? So minus 4 to end. So end is definitely minus 1. Then this must be minus 2. This must be minus 3. This must be minus 4. So from minus 4 till end, so including the last one, will be returned. So that's why I'm getting the words completely, right? However, if you remember the previous example, that if you include the last character, then last character will not be returned. I think it makes sense, right? So try to understand the difference between this one and this one. There is a difference, right? So, and that difference is really important to look at, to think. And if you can think in this way, hopefully you'll never forget. So, in this particular case, I'm not putting the last character, last index, which means the character of the last index will be included, right? But if I include the index of the last character, then that character will not be printed. It will be, you know, processed the character before, the index before, right? So minus 1 means it will go out until minus 2. That's why war is printed. Any question about these two things, about these difference? So the difference between, you know, I'm just trying to put one thing versus movie minus 4 and minus 1. So what is the difference between these two is really important, right? Is really important. Okay. So if you know that, then it should be, uh, should be okay. I think all good, right? Everyone? Okay. Now, the next one is we got the slicing, right? Now, looping over the characters. Since a string is a sequence of characters, it can be used in a for loop to iterate over each character. Each item is a string of length 1 containing a single character, starting with the first character. Okay, we'll see that example. Like, for example, looping over the characters DNA, GATTS. So it's a DNA sequence, right? And there are 4 characters, which is ATCG, ATCG, right? The DNA sequence of everyone. So, or any animal or any plant. So, GA, so, sequence of character. Now, what I'm doing is that this is string literal. So, I used for any variable in DNA. So, what this line will be doing is that it will loop through that literal of DNA and then get every character one at a time. So first it will pick up G, and that G is inside nucleotide or this particular variable, right? So that's why I'm checking that if nucleotide equal to G or nucleotide equal to A, only then print it, right? Which means that in the first loop, what is happening in the loop? In the first index, G is scanned, G is actually analyzed, and it will be printed, right? Second one is A is scanned and it matched to the if condition. The print is going through, right? But T, in case of double T, it is not scanned. So T will not be printed. Again, A is printed, C is not printed again, and then A will be printed again, right? So the main thing is that using a very simple for loop, I can manipulate the string literal. A very simple for loop, very simple way. I mean, this presentation is really, really simple. You can't go more simpler. You can't go simpler than that, I believe. So this is how you can scan each character. Python knows that when you use Python for a variable and in string literal, so you are trying to extract each character at a time, right? And then you can do the job. Okay, in most string one side point, in most string manipulation functions that we'll see more examples. In fact, you can write your own function using this type of for loop, right? So this type of for loop is really, really kind of, I would say, is a kind of backbone to manipulate a string. I would repeat again that this type of looping over the characters is actually the backbone to write any string manipulation or string manipulative function, right? And so on. Okay. Um, so I think that's it. Now, searching again, now actually we'll go through different examples, interesting examples, and that's the power of the Python. Even you can think of writing this function, using, you can think of how you can write this function using for loop, for example, right? Or using the loop mechanism. So the find string method returns the position of the first occurrence of a small substring within a larger string. So where's Wally? So this is the statement, right? So S find W. So when it will find the first occurrence of W, capital W, then that index will be printed. And that's it. It will exit the function, right? Now, another side point is that when you use a dot, which means that S was a class, and we discussed about the class concept last lecture, right? Class or object. And all these are actually internal methods, right? So find W, it will find the first occurrence of W. So you can see that these W is actually missed out, right? Okay, we'll try to understand another function, or we can search another function if it can find the last W, for example, right? So far we found a function which is find. That find is basically return the first occurrence from the starting point, right? Not from the last point, from the beginning point, from the first point. When the first occurrence of this particular W is found, this function will exit by printing its position, its index, right? So which is 0. Now is find Wally. So this is Wally. I mean, that's interesting is that this is a word, but it will try to match the whole thing, the Wally, right? And it found it, and then what is the starting point, which is 0, 1, 2, 3, 4, 5, 6, 7, 8. So the 8 is returned. Okay. So if I read the text here, the find string method returns the position of the first occurrence of a smaller substring within a larger string, right? And sorry. And the position returned is the index of the first character of the matching part of the string. So this is the first character of the matching part, okay? Okay, that's the searching. Now, failing to find. So what happens if I don't find it, for example, right? So if the string doesn't contain the substring, -1 is returned. So -1 is returned when it is not found. So don't think it as index, right? Because we know that -1 is the last position, right? But it's not here. It's just returning the find function is only returning -1 when it is not found. When it is not found. For example, if I try to search s.find, so s is where's Wally and ODL low, right? We try to find it and it will return -1. Now I'm trying to find W, a small letter, right? Small. So uh, um, then actually it will return -1 because this is the capital letter, right? Capital W. Okay, I think it makes sense. So this function will return -1 if it is not found. So using a if condition, you can actually process the program more. That using if condition, if it is not found, then you can generate a report and so on. You can do a printout that string is not found, for example. Now, of course, one question so far is that we can find the string from the starting point, right? And when this first occurrence of W happens, I quit. But what about the Can I search from the end? Can I search from the end? That's a big question, right? Yes, we can do. We can do that. We can do that by using that reverse find, R find. So if I put the R find, then actually we can do the same thing. So for example, if you look at this example, that is the backwards thing. Reverse find is the R find is the backwards thing. So R find E is returning 4 because this is, you know, um, so this is the E, right? That's E is actually 4, but that is the first occurrence, which is the 2. Okay. I think that is what it's happening. I just want to give a quick break, just a minute break. I'll be back. Okay. So again, I'm explaining this thing that the find is string function that try to find out these character, or it can be string as well. When it is starting, it is found, um, the I mean, it returns the first occurrence, right? So from the starting point, when as soon as it finds it, it will just return the value. But if I try to find from the reverse, from the back, right, instead of the first one, it is probably the last one, right? Then I have to use the rfind string method. So you can find the last instance of the substring by using the rfind string method, right? So this is the thing that we can really use that, right? Okay, now um, probably one question I can ask you. Let's see, it's a kind of simple way to think. Suppose uh, you are asked to write a function in which, make it simple, that just try to identify all the occurrences of a character, right? So I mean, if I just write it, the function that you have to write a function like find, you know, all occurrences, and then a character, say the character is W. Okay. Now my question is that how can you write this function? I mean, I don't need the everything. I just need to know the idea. Just in plain English, you can write in the comment that what idea you can incorporate within this particular function, or what you can do. Or if you can write the code, you can you're most welcome to do that. So how can you find the all occurrences? So all occurrences, it will return the index as long as it finds. So how can you do it? What is the idea? I think we already discussed that minutes ago. So is it clear, the question? So how can you write this function, find all occurrences? Just write in few words in the comment. for 0 to minus. So you have to use a for loop, right? Excellent. So very simple, right? So that's good. So you have to use a for loop. Either you can use 0 to minus 1. Did you try it? I'm not sure, but you can use 0 to length, the string length minus 1. Okay. Um, okay, so that's good. So which means what I'm trying to say is that to do this type of function, then you need to write your own methods, right? If you need to do it. And then that we discussed that this scanning is really important. The using a for loop is really important to think, to ponder upon what you can do. Okay, good. Now, next one is case sensitive thing. So the case and string comparison, it's important to keep in mind that the case of letters matters, right? When comparing the string. So when comparing the string, the case of letters, it matters, right? So an uppercase letter, for example, capital A, is uppercase letter is different to a lowercase letter, for example, small a, right? So they're different. So if you try to use the comparison operator, they will be false. They are not equal, right? So look at this example. The art equal art, so it is returning false, which makes sense, right? Because they are not same. Grand Canyon, so within this string literal dot find canyon. So definitely canyon is here. It is starting from 6, so it's returning 6. Now Grand Canyon find canyon. So why it is minus 1? Because it is not found. Because canyon is a lowercase letter, but this canyon is uppercase letter. So the program will never find it, right? So they are not same. So it will return minus 1, right? So this is how we can, this example demonstrates that the case matters, right? It's a case sensitive thing. Now, to ignore the case, of course, ignoring case is really important because in real life, for example, I mean, just think about a data analysis problem in a program. So in today, actually, we'll in the half of the lecture, we'll also discuss about the file operation, right? So in the file operation, these data are written inside a file. So when we read from a file, that file can be text file. For our example, we'll use the text file. It can be database file. That's a different, completely different kind of lecture. But when we try to read from the data, then we don't know really, and most of the cases we don't know the whether it was written in uppercase letter or lowercase letter, right? Suppose my name, probably in my database, my name is written Manzur is completely uppercase letter, but I don't remember. I need to search using Manzur, right? And I need to compare both uppercase and lowercase letters, right? So what approach we can take in this particular regard, right? So to ignore the case, you can convert. So what you can do, that you can convert all of the letters to either lowercase or uppercase before comparing. So if you take everyone into lowercase or everyone into uppercase, then your comparison would be easy. Your comparison is valid in that case, right? So for example, the earth lower, so of course it will return as earth, and the earth lower, they will transform to the same word, right? So then actually it is true, right? So look at the example here. So what I'm saying is that this earth lower, it will return as what? EARTH, all are lower. And this earth lower will return again earth, EARTH, right? So they're definitely same, right? Now Grand Canyon dot upper. So Grand Canyon is string literal. So dot upper indicates that I need to convert it to the uppercase. So the result would be Grand Canyon or all in uppercase letters. And then find Canyon. So definitely it will find that and return 6. But Grand Canyon dot upper, I make it convert to then find Canyon as a small letter. Of course, this is, incorrect because I'm converting to upper. So how can I find small letters, right? So, so definitely it will return -1 because not found, right? So what is the main point in this particular demonstrative example is that in order to comparison in real life, in real setting, most of the cases we need to convert everything into either uppercase or the lowercase letters. Then our comparison would be valid. For example, sometimes our email address, it can be uppercase, lowercase, but if I want to compare my email address against a database, a list of data, then definitely we need to compare everything into either uppercase or lowercase, and my search string as the again lowercase, then the comparison would be valid, right? So these are the kind of practical notation that we need to apply. Any question or any comment from anyone, any observation, you can also write down. We can then discuss on those practical observation. Again, I'm repeating, that string literally, so this literal string literals or string manipulative functions is very, very vital for data analysis, for data analytics or data engineering. Now, next one is string replacement. So, string replace or replace method can be used to replace parts of a string. So, it takes two arguments. So, the first one, the substring to replace, and next is the replacement thing. So, a new string is returned. The original string is not modified. So look at this example. S equal to where's volume. So S dot replace. So ly is replaced by do, right? So ly is replaced by do. So what's really happening here is that this ly is replaced by do, right? So I'm talking about this particular portion is replaced by do, right? That's why I see that change of where's Waldo. Okay. Now S replace W with R. Then I can see that this W and this W is replaced by R and R. So then if I print the S, so this is an interesting thing that the S original string is not changed, not modified. So every time it puts into a temporary another place, or I can assign it into another variable, right? So that's why it is saying that the new string is returned, the original string is not modified, right? So that is the thing. Okay. Now, if the string is not found, the string is returned unchanged. The second argument can be an empty string. Using an empty string will result in the found substrings being replaced with nothing. For example, removed, right? Um, so we'll see. Okay, so yeah, this example is really interesting. That is actually discussed just a slide before. Suppose there is a string literal in which A, E, I, O, U, right? All the vowels, right? All the vowels are mentioned, right? So S input entered some text. So it is asking to give the input of some string literal, right? So like suppose an example, a fox is orange is given. So for vowel in vowels, so I'm doing the loop, right? So from the vowels, every vowel is actually returned and put into the vowel, right? And it is actually checked against the input string, which is S. So this S is the user defined string. So in the string, I'm replacing you know, each vowel with a blank character. So, or a empty string, right? Empty thing. So if I put the empty string, then that particular vowel, if any of these vowel is found within the user string, then those vowels will be deleted, will be removed, right? So that's why a fox is orange. So you can see that space is there, A is removed, F is kept, O is removed, right? X is there, I is removed, but space is still there, right? Space is not removed, right? And S and RNG, right? So all these vowels are actually removed from here, right? And so on. Okay. Um, can I ask a question on this particular example? How can you also remove the um, space that the white space or the empty space? Not empty, it is the space character. How can you remove that space character? What change or what modification you need to do in the code? Just write in plain English, or if you want to write the answer in the code, you can give the idea. The space. No. Can you put anything here in this string? Space. Looks like quotation mark. Um, no, just try it. I think I add. No, no, not that. I'm just trying to. You can also try. I'm also trying, and then I'll show you that thing. Okay, so define an absence. Okay, let's see. I'm just trying to do something. Yeah. Okay, okay, anyone got the idea? Okay, let's see. I mean, I'll share you the screen, what I'm showing. Um, yeah. So you can see that. Can you see that? The example is, I think, clear to you, right? So if I just, yeah, if I just run it, I mean, suppose if I type a fox, for example, you can see that still this character is there, right? Because A is removed, right? And then space is there. Okay, so what I'm doing is I include that space here. I include that space here, and then if I just run it, then a fox, you see that no space is there. So space is also removed now. So which means that, of course, the name is not right. I mean, it doesn't matter. It's just a variable. But whatever character you include here, it will be replaced with empty string. So that space within the text, this is the space within the text, will be removed by this empty space. Does it make sense, everyone? Yes. So the space is removed because I put the space here. That's why I put the space here. But if I don't put the space here, then it will not be removed. Does it make sense? I mean, did you understand the difference? That's my point. Okay, excellent. So, sometimes it's really useful to deal with the empty spaces. Correct. Because, yeah. Yeah, correct. All spaces will be removed because of this for loop. Because of this for loop, it will be dealt with, right? Make sense? So it will be dealt with. Okay. Because everything is compared within the S, which is the input string, right? It will replace any of the character inside this string with the empty. Did you, is the answer clear? Or do you want me to explain again? So what I'm saying is that if you put the space here, right? If you put the space here, then you can see that Fox running, right? So you see all the spaces are actually removed, right? And all the vowels, right? So that is actually considered. So a small change, but it can do interesting thing. Okay, good. So I go back to the slides. Okay, next one. Okay, so this is your task. So what is the result of the following Python expression? So no worries, Oliver are fine. Yep. So what is the result? What do you think? One, right? R find, oh, so why did you say one? I'm not sure. Let's see, two, right? So, so it is actually four. I mean, it's a reverse found. So it is start from the end, right? From the end. So here, this zero, right? This zero. So this zero is actually zero, one, two, three, four, right? You have to count from left, right? Read. Sorry. Uh, okay. Is it okay? So make sense, everyone? So I'm reading from here. Capital O is different to the lowercase o. So our find searches backwards. So it finds the last O, and the index of the last O is 4, right? Index of the last 4 is 4. So this is, remember that this is the last one. This is the, we're talking about the small O. This is the last one. So that must be 4, right? Because 0, 1, and then space is actually 2. W is actually 3, and then the 4. I think all good, right, everyone? This is what's really happening here. Okay, excellent. Now, next one is F string. I think we discussed that last lecture probably or the week before. Now, we're repeating again. So, we went through a lot of discussions about formatting, and we need to use the backslash, right? The quote, single quote, double quote, and so on. If string is one of the most popular, one of the popular thing. Uh, it will remove a lot of difficulties. So far we have built strings using the plus operator. So this is called string concatenation, right? That we started discussing from week 1 probably, or week 2. So in string concatenation, the plus sign is used, and we know we have the integer float. We need to convert to the string function. That is a lot of additional work, and then we can concatenate. So for example, account equal to 1, balance equal to 23, print account, you convert it to the string, and you can use the concatenating function, which is the plus operator. Balance is dollar, then string balance. Again, change that floating point number into string. All right. Two things to focus on. One is concatenating the plus operator. Another is the string function, str function. To avoid that, we can use the if string. So Python provides if strings as a convenient way of building strings. So an F string is a string literal prefixed with an F. When writing an F string, you can include Python expressions by using curly brackets. This part of an F string is called a replacement field. F strings reduce the need for plus and str. So these two things, right, reduce the need for plus and str. That is the advantage of F string. So, for example, without F string, we know this example, we already discussed that. But with F string, we just use print F and then a quotation account, use the curly bracket AC. So ACC would be replaced by the value, which is 1. And balance is dollar and balance. So dollar and the value 23 would be printed. So now it is non-messy, basically. The first one is really messy. This one is, kind of clean, kind of formatting. There are multiple ways of expressing a number. For example, the number 5 can be written as 5, 5.0, 5.00, etc. A programmer should be able to choose how a number is displayed depending on the application, right? For example, dollar amounts are usually expressed using two decimal places. For example, dollar 1.99, right? So again, we are going towards more precision type of thing. Precise distance measurements might be expressed using many decimal places. Sometimes only two decimal places are not suitable. In some scientific calculation, we need up to decimal points 6, 7, 8, 9, whatever we need. Okay, that's the more precision. Okay, so you can specify how values are to be formatted. So now we will be learning that how we can do that, how we can use 5 decimal places, for example, or 2 decimal places, or 100 decimal places, or on the left side, what we can do in case of integer, in case of float, in case of string, the left alignment in case of text, and so on. Everything we'll be discussing. So this is achieved using a concept called format specifier. So even if you search in AI tool format specifier in Python, you can see a lot of documentation, right? That is really useful when you really want to learn in depth. Format specifiers are actually quite in depth and allows for lots of customization. We'll now cover some common kind of format specifier. But this is not the end of the story. You can look at the help file to look at more. Now, look at this example. Format specifier. So if it's a if string and then 1/3 is 1/3 and then the colon. So colon is actually this expression is to be written, the result of this expression is to be written using that format specifier. So 0.4f, right? 0.4f. So the format specifier is separated from the expression using a colon. So now we'll discuss in the next slide the exact thing, but uh, in this particular slide, we are just giving the idea that how it can be written. So the format specifier is separated from the expression using a colon. So this is the expression, which is the numeric expression, and separated by a colon, and then this is the format specifier. So this expression is to be written using the format specifier notation. So the 0.4 floating point, f. So f is a floating point, so 0.4 means after decimal point, there must be 4 numbers. Okay, we'll see that example now. Number of decimal places. You can specify the number of decimal places shown like this. So x equal to 0.6666. So if I put f, form x is the value, then colon is the format specifier, right? So this is the format specifier that we discussed here. So format specifier 3f, 0.3f, which means that after decimal points, there should be 3 value. So it should be 666, but that last 6 would be rounded to the next integer, right? Because it is more than 5. We know that, method. 6 is 7. Now look at the next example, x then colon 0f. So colon 0 means after decimal point there should be no number. So which means that I am really asking this number to be rounded to 1, right? Because after decimal point there should be 0, nothing, which means that it must be rounded to the nearest integer, which is 1. Now x 0.6f. So after decimal point, there should be 6 value. 1, 2, 3, 4. So 4 up to 4 there is but we have to add two more numbers, two more digits. So since this is 0, 0, so that 0, 0 will be added, right? Any question about the, and that's called actually trailing zeros will be added if necessary, right? Trailing zero will be added if necessary. Of course, technically it is the 0 is here, right? Any number, if it's not 0, it is actually 0 after the decimal point. So, but I have to show 6 places. That's why there are 6 numbers are shown actually. Any question from anyone? All good, right? Okay. Now, yeah, number of decimal places. So the letter F in the format, the letter F in the format is specified indicates that the value should be presented as a number with a fixed length fractional part. This is called the presentation type or format code, right? So suppose x 0.66 3f, we discussed that. So yeah, we already discussed that. Now this one, the number of decimal places, the dot slash is the format specifier indicates the number of decimal places. So yeah, width. Okay, now the minimum space. So this width is an interesting thing. The minimum space that the formatted value will occupy will be specified. The width in terms of the number of characters. The extra room is filled with space characters. So that is really important one. Sometimes extra room is there. Suppose I'm asking them to print 6 character, but there is only 3 characters. So what needs to be done, right? We need to put some extra character. It can be white space and so on. Useful for aligning program output, right? Sometimes alignment. So in case of alignment, is it left or right? So today is in the lab, one example is given in week 6 lab tutorial in which actually this alignment thing is actually discussed finally. Okay, now look at this thing. Notice that spaces are added to the star to ensure that minimum width is met. So 123 and the format is specified is 60, which means I need 6 digit. 6, but there is only 3 digit, right? So so what's really happening here that this is the 6D. So the left kind of thing is actually added, right? So 1, 2, 3, 6D. Yep. And here 2D, right? So 2D, of course, 2D. So I need to print everything, right? This is a minimum, but I need three digit because I need to put all 3. Okay. Now this kind of the other numbers are on the this is the white space on the left side because it must be 6 total 6 digit, right? This is the minimum width. That's why I need to print. But if it is a 123, it is already 3 digit, 3 number, 3 digit. So I cannot use using 2 digit, right? I need to use all plus 1, right? That's why 123 would be printed. Okay, so there's the minimum, but the maximum is 3. Now 0.11 and 6.2f. So 6.2f is important, which means that in total there are 6 characters including the decimal point, but 2 is actually after the decimal point, there must be maximum 2 digits. So that's why 0.11. However, if this is 6 character total, I need to put some, the extra spaces, right? to adjust that. It is a kind of, right alignment kind of thing. I think makes sense, right? Everything. So 6. So you can see that there are 2, right? 2, 3, 4, 5, 6. Total 6. So total 6 and 2 is after decimal point, there are two numbers. And after decimal point, there are two digits. I think it makes sense to everyone, right? Okay. So now look at the next example. Use the D presentation type indicates that the value should be presented as a whole number without a fractional part. So when I use the D, then no fractional part would be printed. Remember that. But if I use the F, then the fractional part would be printed. So D 123 and D 123 and 6, therefore, there are white space. Now 11.6.2, so I'm using the fractional part. Now, what problem is happening here is that it is a 12.3. It is definitely a float data type, but I am using 6D decimal, so it will show an error because the error is showing that unknown format code D for the object of type float. So for the object of type float, I cannot use D because D indicates for the whole number. I think makes sense, everyone, right? So if it happens, then this is the reason, and the error message is clearly indicating the reason of the error, right? So we don't need to be panicked. That is actually giving the idea. Okay. Now look at this example. That is a timetable. I'm trying to print a timetable. So here's a timetable program that produces nicely aligned output using the format specifier. So the format specifiers is a really powerful thing to give a printout in a the best possible way. Sometimes in times table, for example, if you don't use the format specifier properly, the look and feel would be completely problematic. So to give a really good look and feel, I need to use the format specifier appropriately. So a equal to int input times table. So for b in range 1 to 13, what I'm doing is that printf a colon 2d. So two decimal numbers for the first, and b 2d. 2d, that's why some white spaces are generated, and also due to that, and a times b 3d. So for 3d, sometimes there are two digit, automatically it is actually produced. So the white space is there, plus additional white space is for the 3d kind of thing. It is kind of right aligned, right? Right aligned. So because I know that maximum 3, it can go up to the 3 digit, but minimum can be 2. So for the 2 digit, it is right aligned. That's why an extra space is there. But for 3 digits, it's fine. But if you don't do it, it will not look good, right? If you don't use 3D here. Makes sense, everyone? Try to think that how that format specifier is actually producing this type of coding. So can you see how the spaces automatically added to the smaller numbers result in visually pleasing formatting? So this sentence is really important, right? Right? So the spaces automatically added to the smaller numbers result in that particular thing. And to do that, I carefully used 2D, 3D, on all these particular notation. Any question? All good, right? Okay. In case of string, so in case of numbers, we have found that it is actually kind of right aligned, right? In a kind of right aligned. But in case of string, we'll see something interesting. So string values can also be formatted using a minimum width. In order to format a string, you should use S. So for decimal, we use sorry, for whole number we use D. For floating point, you used F, and for string, we're using S, right? You can only use S when the value is a string. So 8S, 8S, so, hello. So hello 8S. So can you see the printout that three white spaces are there? Why that white spaces? Because I use 8, which means that I want minimum 8 character. But in hello, there are 5 characters. So I need to add 3 white space, right? Second point, it is actually left aligned, right? But in digital, in number, it was right aligned. But this is now left aligned, right? This is an interesting. So what about this one? Any question about this thing? I think you need to point note that this is a left aligned. Now, 96 is a number, it's a decimal, it's a, sorry, it's a integer, but I'm trying to use 8s. So definitely error is produced because this is the string. Format specifier is for the string type, but this is the integer number. That's why the error is generated. All right. Okay. So you can only, that's why it is saying that you can only use the s when the value is a string. That's why this error is actually happened. Alignment, I already discussed that it is left aligned, right? Strings are left aligned, unlike numbers. So hello 8s, so hello, and then you can use the extra spaces. Now, if hello is greater than 8s, so when I use the greater than sign, it actually indicates that I want to do right alignment. So this one is used for the right alignment, and smaller than is used for the left alignment, right? So this is the right alignment, this is the left alignment. So when I use 42, look at this example. 42 is greater than 6D, so it is um, left alignment. But when I don't use anything, by default, the integer is actually right aligned, right? But in case of a string, by default, it is left aligned. But if I use double greater than, then it will be kind of right aligned. Does it make sense, everyone? So you can force a particular alignment using smaller than sign for left alignment and greater than sign for right alignment, right? This example is demonstrating. But by default, for a string, it is left aligned, and for the numbers, it is always right aligned, right? For the numbers. Okay, that is the concept of alignment in case of format specifiers. Now, can you try to answer that, please? So what will the output of the shown program be? So speed kph equal to 40, time h equal to zero point 0.5. So print format specifier and time h times is less than 6.2f. So can you try to think what should be the output? In what format? In what format the output would be? So of course the result is what? 4 times 5, right? 20, right? So how can you print the 20? So point 2 is 20, right? Let's see. I'm just going through the exam. So it should be 20, and then point 2, right? Point 2 means after decimal points there are 2. There are 2 digits, right? But it's total 6, which means there must be total 6 characters, right? So 1, 2, 3, 6, right? Right. So note that the space between the 0 and the slash, there is a extra space, right, between that. Now, one thing is that because of the smaller sign, it is becoming left aligned. Because of this particular sign, it is becoming left aligned, right? I think all good, right, everyone? So this is basically happened here, that using the format, I'm just trying to put the idea. Any question from anyone? So that was discussed. Okay, I just will be starting the file operation. I want to give a kind of 10 minutes break because then we'll actually continue the next one. Okay, now we finished the first part of this lecture, which is the string. Now, before jumping to the file lecture, now I would like to show one thing from one of the website, um, which is these W3 schools, or you can find any other websites as well in which you can find all the string function. We actually went through find, and there are other like our find, even our index is another function. And there are some functions which sorry, the strip function, which actually strip function which actually returns a trimmed version of the string, trim out the white space on the right and left portion. Every function, for example, if I look at the strip function, if you click it, and then you can see the example, right? Like in this type of example, you can look at the try to yourself thing in which you can code and try. So to prove the concept, you can actually investigate all the functions. Now, this is actually all the functions is inside the string class is actually discussed. So I would like to give that into the chat so that you can look at all the examples, right? Okay, good. Now, the next one, I have to open. This one. Okay, so in case of file operation, I think I will straight away go to the Colab to show you the file operation because there is some thing we need to consider. But before, what is file, right? So the text file is in which, all the uh, any data, any character you can save, and it is a text file. So it is a simple kind of is like a string saved on a computer's storage drive. So probably it is a simple definition that a text file is like a string saved on a computer's storage drive. So it is very likely that you have come across text files before. Some examples of the files which are text files include .txt file, CSV file, HTML pages, and Python source code. Even the Python source code is a text file. As a general rule of thumb, if you can edit a file in Notepad, it's a text file, right? It's a simple definition. If you can edit, if you can, edit and open the file, it is a text file. Binary files. Files which are not text files are called binary files. So binary files do not fundamentally represent the data using human readable characters. So this is not here. Some examples of the files using binary files and are not text files are JPEG images, MP3 songs, zip archives, and Word documents. So all these are actually binary files. Opening files. So in order to read from or write to a file, it must be opened. So in Python, opening a file successfully will result in a file object which represents that file. So we need to create a file object in order to open a file first or write a file. Okay, so for example, F open, so open command and colors.txt file. Suppose we have a file in which red, green, and blue, these texts are mentioned. It is a colors.txt. So if I open the file into F, and if I type the F, I can get the information that it is a, you know, its name is io.text io wrapper. So that is the kind of name, and this is a file name and read mode. So it was open in read mode, and its encoding, data encoding is UTF-8. So and so this is basically the idea that the file is actually opened. Okay. Now I'd like to probably show you this demonstration that during the lab I'll be showing as well. So just okay. Now um, something. I would like to probably show you a basic idea that Colab how we can do the file operations. Okay. I think you can see that, right? So the first thing is that in the Colab, actually, you can create a file. You can create new file. You can read from a file. So the best thing, if you look at the mouse, if you look at the thing, this is the folder files, right? There is an icon on the left side. If you click that, you can see the file of your existing files or folders, right? So what you can do actually here, actually, you can create a file. You can upload a file. You can upload a file. You can just right click. You can create a new file, right? So colors text, I just created a file. So if you double click it on the right side, you can see the content of the file. Is it okay? Can you see? Is the screen okay, everyone? The red, blue, green, right? Okay. So now, um, what you can do is that, what I can do is color text. So here, I can do the copy path. So I want to know the path. This is really important concept. So I can know I can create copy the copy path, and I can simply just Control V. Then you can see the path system, your path, right? So that is a unique thing in Colab. Basically, you need to put the file with the path name, right? Otherwise, the file cannot be found. Of course, in the basic, you can do that. But if you can use multiple folders, suppose if you can create a folder, and inside the folder, if you want to create a file, then you really need to know the path. Okay, so so once I copy that, I can actually do the code like the F open thing that was discussed. So for example, if I just run the code here, F equal to say open, right? And then Control V, which is the path, right? And then I want to print the F, say, right? So if I just run it, you can see that, okay, the reason is that I need to put the code, right? Then if I just do it, then yeah, you can see what I'm talking about, the text. So this is the this is what I'm expecting, right? So so I'm trying to kind of, sorry, compare that, because uh, it is in Colab. The only thing is that you need to put the path, then it should be fine, right? Okay, so I'm now going back to the thing. Okay, so this is the command prompt, but I'm talking about, where we can do the thing. Now, I want to also demonstrate that um, here at the same time, the same thing probably I can demonstrate using the Python, but you need the collab. That's why I just showed you the collab thing, because you have to do the work here. Any questions, just ask me. Sorry. Okay. The next one. So a file object has the information Python requires to access the contents of a file. It also contains the name of the file. A file object doesn't represent the data contained within the file. Data is accessed using methods on the file object. So definitely, if it is a class, it must have many functions, the way we looked at the string, right? So data is accessed using the methods on the file object for reading and writing data. Okay, so when there is no file, it will throw an error, right? We know that. That also we discussed during the string, when you're discussing the string. Okay, so a call to open can fail, which will result in an error being raised. For example, if the file doesn't exist. For now, we'll simply assume that the files we are opening are accessible. In the future lecture, we'll discuss how to handle the errors. So here, file not error found. Suppose I try to open 404.txt file, but this file is not present, then actually it will show this particular error, right? And so on. Reading. So look at this particular code. So if I use a read function, then I can look at the content of the file. So if open color, using the file handler, I can just open this text file, and then I read f.read. It is into the S, and then I can read the S. It will just print like this in the command prompt. However, if you do that in Colab, you can basically see the formatted output. For example, I go back to the code. So you see that I open the file, right? I run it again, and then I just want to read that, and then I print the file. So I can see the content of the file is printed now, red, blue, and green, right? So this is what I'm talking about. But in command prompt, you don't need to put the print command, right? You just type S and it should print. So I'm just explaining the thing. Okay. Now, once again, now how can I read line by line? So sometimes it is not a good idea to read all of a file at once. So for large files, this could be extremely slow. So very, very large files might not fit in memory. So in other situations, it might not be convenient to work with the entire file all at once. So the read line method can be used to read one line at a time. So remember that we use the read method to read everything. But now I want to read line by line. That's why I use the word line, right? Read line method. So look at this example. Now, if open colors text, now if read line, so it will pick the first line. So in Colab, you have to use print, right? Print and then if read line. Then actually you will not see that in. It will be printed, right? Directly. So red with the new line, it will be printed. And if read line, the next line, again read line, the third line, and next read line, empty. Nothing is there, right? It is ended. So reading a line, advance the cursor position in the file. Each line includes the new line character at the end. Once the end of the file is reached, calls to read line, return the empty string. Return the empty string at the end, right? Okay. Right. Okay. Now, reading line by line. The new line character can be removed from lines using the string slicing or string replacement. For example, there is a new line we can see here. Um, we can see here is this one, right? So how can I delete that? How can I remove that? I can use this particular slicing operation, right? So from starting point that we learned from last lecture, that from starting point it goes to the last, not to the last, before the last character, right? So before the last is actually the last character is the new line, so it will be printed as red, and then line replace new line with empty. So you can do either option. You can do either option, right? But we use actually this thing. Returning to the start of the file. So sometimes what happens is that you can return the cursor position to the beginning of the file by using the seek function, right? Method, and passing 0 as the argument. This allows you to read the same line multiple times if you wish. So just think about this example that I used read line, then the first line is printed, then automatically the pointer is going to the second line automatically, right? The next read line will read the next line, and automatically after this function read line it will point to the third line, right? And then third and fourth line, right? One by one. So how can I go back to the first again, right? I cannot go back. So you can go back using this seek method. So seek 0 means you go to the first pointer. Then if you, so for example, I read the file, then I use the read line command. It will read the first line, which is the red. Then I did read line again. It print the green, right? The second line. Then I use the seek 0. So it goes to the 0. And then I put F read line. It will print the red line again. It is again, right? Because with seek, after the second line, it go back to the first position again, right? So that is the idea of the seek, right? By which actually you can go back. So this allows you to read the same lines multiple times if you wish. Okay, that's how it's a powerful thing. Okay, now we can read a file using the loop, the for loop. So for convenience, Python allows you to use a file object in a for loop. The file object acts like a sequence of lines. Behind the scenes, text will be read from the file one line at a time. Okay, look at that. um, let's see. Yeah. Okay. Um, I'm just trying to identify one thing. Okay. So file name, input, enter file name. So I gave the file name and then that file is there. Present, suppose assuming the file is there. So it will open the file in the file, then print. It will do a printout like this. And then for line in file, so in this file, right? Very simple coding, right? For line is actually every get line, right? So every line, it will scan and then print line code, colon minus one, right? Colon minus one. Okay. Then if you do that, it will be printed. Okay. I want to demonstrate that in Python. There's a reason for that. So I just copy that. Um, okay, so I think I can use, I don't need that file name. Just trying to change the kind of thing. This context. Okay, I'm sharing the screen. Okay, so here, if I just run it, so I can see all the new lines, right? So, but so if I just don't use any of these indexing, so I'm actually not reading the new line character. right? I'm not reading the new line character, right? So if I just put the line, then I can see the gap here. So who can explain me what's happening here, right? I can see kind of a space, right? But if I use colon -1, then I can see the difference is that all are kind of very close by. Can you explain what's happening here? Can anyone explain? So what's really why it is like that? So in this case, actually, I'm ignoring the new line character, right? But if I don't use the slicing, yeah, print till, yeah, excellent, very good, right? So that is actually happening. So, but if I use that, then the new line is actually printed here. Okay, good. Now I'm just going back to here. Okay, based on your understanding how readline works, what do you think the result of calling read twice in a row on the same file object would be? What do you think? Twice in a row on the same file object would be. Okay, just the first call returns the entire contents of the file as a string. The second call returns an empty string. This is because, so this is the reason. This is a really interesting thing. This is because after the first read call, the cursor position is at the end of the file. So next, if you just read it, it will return empty, nothing, right? So this is a really interesting kind of observation. Any question, let me know, right? Now, we have to do the write text file. Reposition the cursor. Yeah, that is the solution. Okay. Um, Now, writing text file. So when opening a file, you can specify a file mode. The file mode determines whether the file object allows reading or writing or initial file cursor position. So initial file cursor position is also important thing. Whether existing files should have their contents kept or erased, right? Whether the file should be created if it doesn't already exist, right? So all different modes. So the default mode is R, which is read. So if you don't put R, it's okay. For example, we already use this particular portion, right? But it is the short notation of that R thing. So R was there. There was actually two parameters. There were actually two parameters. So the first parameter is the file name, first parameter file name, and second parameter is the read mode. So by default, read mode. So if I don't write anything, it is a read file. I can read from the file. However, there are other modes available. If you can see from the examples that the read, which is the read mode, but no write mode, right? And then, you can keep the content. Yes, create file. No. W is the write mode. You can actually write, but not read. Start position, keep content. No. Create file. Yes. So when I create the file W, it will be deleted and created again. A is the append mode. So it is actually appending. At the end, it will be appended. R plus doing the whole thing. W plus is also read and write mode, but keep contents, no. A plus is actually appending and from the end, right? So mainly append is needed. W is also needed and read. So whatever you need depending on the situation. So for example, when using the mode A plus, it will be possible to both read and write if the file, so that actually is demonstrating that thing. If the file exists, existing contents will be kept. If the file doesn't exist, it will be created. The cursor position will initially be at the end, right? Okay, writing text. So to write to a file, you must open it using the file mode, which enables writing, such as W. So open results text.w. You can write to a file using the write method. So when you have finished writing to a file, it should be closed using the close method. This ensures that data is saved to the file. So when you use close in the close method, that actually ensures that the data is saved to a file correctly. So here, that f open gifts text w, and then I'm writing. So it's a w mode, which means that if the file is already there, it will be deleted and it will be created again from the beginning, from the scratch. And I'm writing as a first file, a gift is nice, new line, and then write, but two gifts are better, new line, and close. So when I do it, I can expect a file to be created here, right? Okay, so I'll show you this demonstration because for a reason, because you have to do that in the lab, similar thing. So I just go to the Colab, and you can see that the file is there, right? The file is there, and then there is no such file here, right? So if you just refresh it, okay. So now I just click it. So when I click it, the gifts text, it must be written here. So I just refreshed and then I can see the gifts text is created, right? So remember that you can find it using this particular icon, right? So if you click the gifts.txt file on the right side, you can see that the content is shown here, right? I think it now makes sense, right? This is how you can create and manage the file. Okay, uh, now the next one is um, opening an existing file with the file mode W or W plus will erase the contents of the file, right? So if you want to keep the existing contents of the file, you must use the append mode. So remember that. So W or W plus it will delete, right? So only append mode will try to keep the existing data. So be very, very careful when you use the write mode, right? It may delete everything and start from the scratch. So for example, here, work tracker. Um, so print enter work completed and then input slash. So it will just wait for the input. So whatever you're typing, it will take, right? So it will then, once you click the enter after typing some text, then it will open a new file, log text file with a write mode, and it will enter into all the data that you have put into the work, and then the file is closed. So a new file is created. So the word tracker. So if I just run it, what will really happen is that so once you run that code, right? Once you run that code, then it will ask for the enter like that. So I want to demonstrate that quickly here. Um, so you can see that this is the code file tracker. So if I run it, it is just enter work completed. So my work one, enter, and then it is basically done. It's basically done. So if you look at the left side work logs, if you click it, then you can see my work one, right? Now, if you run this code again, I'm just writing it, and then my work two. So you can expect, because this is the write mode, you can expect that the previous log will be deleted, right? So if you enter it, then if you click the work log again, then you see my work two, which means one is deleted, right? So this is how you can really, track what's happening here in Colab. Okay. Now, so that is actually demonstrated here, but I showed you into the Colab so that you can experiment that into there. Okay. So any question, please ask me. Now, in case of append mode, this is a really interesting one. I can expect, so you can see this append mode, right? So in case of append mode, I can expect the data will be kept. The data will be kept. So I demonstrate that into the Colab. So here you can see that instead of W, I can just put the append mode, right? And then I run it again. So I can use my work free, enter, right? Enter, and then I click that, and then you see that previous work is existing, right? Plus the new work is appended. Now, if I run the program again, say my work 4, right? And then if you just click it here, you can see that 4 is appended. So everything is actually appending, right? This is what the mode is demonstrating, right? Okay, now just come back to the files. So that is actually demonstrated. Okay, it's your turn. Can you please tell me that what should be the output of this particular piece of code? What will be the contents of output text after the program finishes running? So you can see that f open output text w. So for I in range 5, f dot write stri and f close. If you can write the answer into the text. So we are, taking more time in the lecture because the lab would be quicker. So it should be adjusted. Anyone can give the answer of this? Or any confusion, anyone? I is printed once. No, I mean, I in range 5. So, which means range 5 means what? From 0 to 4. From 0 to 4. Is it okay? From 0 to 4. So it will be printed like this. 0, 1, 2, 3, 4. Is it okay now? Yes. But for yes, but for W. Okay, I know what you're thinking. Okay, no, this W is actually no, it is not override because it is not a looping, right? So the loop, yeah, it's a good question. The loop actually starts from here, right? This is the loop. You got it? Because it is not overwriting an existing entry, correct? Yeah, 5 lines or text. Yeah. So that is actually inside one open mode file operation. But if I would run the loop and open the file inside the loop, then you are right. Only one time. Does it make sense? So because this is actually opened first line and then you use all the writing and then when you close it, then everything is written. However, if you use that somehow inside the loop, then only the last one would be printed, right? Last one would be printed, but that's not what we're doing here. I think no other question, right? In this case. Okay, so since the strings we have brought to the end of file in a new line, they were all written as part of the same line. Okay, now the file and directories. There are two types of entries in a computer file, like files and directories. A file contains data, and the directory contains other files and other directories. So we know that, right? Directories are sometimes called folders, right? The open function is working with both files, with files and not the sorry. The open command works only for the file, not the folders. So a path is the location of the file, and I already demonstrated how to check the file, right? How to check the path in the Colab. But also in Windows or in Mac, there are different ways to find the path. So, for example, if you look at the example that on Windows, C slash program files, Microsoft Office, and Mac OS like slash forward slash, but in Windows, it's a backslash. And every file and data on your computer has a path. The first argument to open is the path to the file to open. Absolute path. In case of absolute path, we have to put the C drive and exactly like this. But relative path is relative to the current directory where I'm working, right? And so on. The OS module is one of the kind of module OS similar to the math or other system module Python provides many functions for working with the file system with paths. Many of these functions are part of the OS module. So if you put import OS, you can get a lot of functionality to do. We'll see some of the examples, right? So to see if a path refers to a file, use OS path is file path. So is file, it will return true if the path refers to an existing file. Okay. To see whether a path refers to a directory, use os.path.isdir is directory or is dir path. True will be returned if the path refers to an existing directory, right? It will return true. Okay, now this example, right? Suppose import OS path, import enter a path, right? And then, sorry, OS, if OS is file path, then if formatting string, path is a file, otherwise it is not, it is a directory, else it doesn't exist, the path doesn't exist. So we are checking using the if condition. So suppose there is a directory, there is a file, then I check that using this command, then this program runs in this way. Now I want to demonstrate it into Colab. I later give the example, share the example basically. Um, so here I can see that suppose this is the enter a path and I'm asking for the file. So this sample data is a folder. Can you see on the left side, this is sample is a folder because inside folder there are a lot of files and these are the files, right? So I'll check with these two things. So the first one is a folder and how to get the path? Just simply right click and get the copy path. Then you can get the path, right? Okay, so I just copy that so that I can type in, right, when it will ask for. That's why I just copied it. So I just run it, then enter a path name. I just put this thing, enter, then it is a directory. And if I put that, it will show as a file. So I'm just showing it because the demonstrative example is not in Colab. So I just, you can, run it from there by looking at the video. Okay, now I share, I'll go back to the thing. How to create a directory. So these things are really easy and quick that I can use os.make dir. Make dir means I'm making a directory, I'm making a folder. So if I have to make directory false, because what it is saying that OS path is directory, my directory. So it is not a directory. There is no such directory existing. That's why it is returning false. But if I to make directory my dir, then if I type OS path is directory my directory, it will return true. So is always indicating it's a boolean, right? So if it is a directory or not, if it is a directory or not, right? So it will return true. Okay, so another point to remember here is that um, so yeah, short, it's short for the make directory. So I think that's it. So we can use the OS. But now in case of Colab, you definitely used to use the print command, right? To identify it is true or false, right? That's the difference only. But this print command is not needed in command prompt that is shown here. You can show the listing the directory entries because once you enter into a directory, you can show all the contents, right? In a directory list. Now, in case of directory listing, there's an interesting example is that you can also rename file and directories. You can rename using the rename command in which you can first use the source path and the destination path. It will be renamed. You can also remove a path by using the remove command, then it will be removed. Remove directory path. If you do that, the directory will be, it's simply similar to deleting a folder, right? Deleting a folder. So this list is really, really important, but you can find it using the AI tool that the file system operations reference table. You can search it. You can get a lot of examples. I'm just showing quickly, quickly. Um, so Python, just trying to find. So even in Python, you can see the same list is actually you can identify. I'm just showing you so that just because this list is a huge list, and it actually gives you all the ideas, right? So I think you can see that, right? Check if a file exists by using this, and you can specific example you can just copy and paste and can get more ideas. on the file operations, right? Okay, I'm just going back to here. So is an existing file, is an existing directory, create a directory, list a directory, rename, remove a folder, remove directory, and so on. Okay, it's your term. Using the file operations to explain this lecture, how might you go about deleting a directory containing files but no subdirectories? It's a big code. I'm just quickly going through here that you could list the files in the directory, delete those files, and then delete the now empty directory. So for file path in os.list directory, so from the list directory you can get all the file names, right? And then p os path join d.file name. So with the path, I'm joining the file name and then I'm removing that. And then finally, once I remove all the file, I can remove the directory, which is the empty directory, right? Any question from anyone? Hey, I think I finished these one. Uh, so probably what I'll be doing is that after probably 5 minutes, I'll be starting the lab after 5 minutes, right? I'm closing. Any question from anyone? Otherwise, I'm closing the session. Okay, all good. Thanks for joining this session. I'll be starting in 5 minutes the lab. Thank you all.